My name is Dr. Helen Lever, and I am here to give you a short tutorial on the laws of stratigraphy. This tutorial expands on some of the material covered in Chapter 1 about stratigraphic successions and how we interpret these in the rock record. The first principle or law that I need to mention is known as the present is the key to the past. This principle can be basically stated as that the current processes that we can observe at the present day are the same as those processes that acted in the past, throughout the past. Therefore, we can make observations and conduct experiments on modern day processes, and that these observations and inferences can then be projected onto the rock records that we are observing from the past. The next three laws that I want to talk about were postulated by Nicholas Steno in the 17th century. He postulated three different laws in a discussion or series of dissertations on stratigraphy that he had observed. The first law that he talked about is known as the law of superposition. This law states that rock layers are younger towards the top of a succession. If we care to imagine this, we have a layer of rocks or sediment that is deposited, and that needs to be deposited first before the layer on top of it is deposited. And after that, another layer is deposited, and so on, up succession in depth and also in time. That means that the layer at the bottom is the oldest layer, and the layer at the top is the youngest layer. This then applies to all the rock records that we observe, where we have the oldest layer at the bottom of the strata and the youngest at the top. So long as that succession has not been too tilted so that it's overturned, this will always apply. So whenever we observe a rock layer succession, we can understand that the oldest layer is at the bottom and the youngest is at the top. The second of Steno's three laws is known as the law of original horizontality. This law is basically just as the title states. It says that the original strata were deposited horizontally on the rock surface or the surface created by pre-existing strata. Now, we know, in fact, that this is not entirely true. So we know that strata can, in fact, be deposited at very gentle angles, in particular depositional environments, or really, really locally at quite steep angles if we're dealing with sedimentary structures. So that's different ways that this has changed since it was written in the 17th century. Our final of the three laws that Nicholas Steno proposed is known as the law of original continuity. This one states that originally the layers were deposited both horizontal and laterally continuous. So as well as being horizontal layers, they were also very, very, very continuous. He states over the whole Earth, but that we know is not in fact correct. What we now know is that although a whole layer may in fact be quite continuous over at least a basin scale, actually there are different facies, different grain sizes from sand to mud to shale or clay or perhaps limestones as you move through space along that layer. The whole layer or time is continuous, but the individual lithologies in that layer do change laterally, and those changes are important. The next law was postulated in the 1840s, and this was postulated by a guy called Walther, and is therefore known as Walther's law. Walther's law is about these lateral translations or transitions in facies and how that stacks up into vertical transitions of facies. So his law states that in a conformable vertical succession, you should get the same vertical transitions of facies as you see horizontally. So those vertical transitions of different facies or lithologies should be the same as the ones you'd see in space horizontally. So this is where I want to do a little demonstration of this. Let us imagine that we have 4 different facies, and each of these circles represents a different depositional environment, the processes in that depositional environment creating a different lithology or facies. If we have them, this is in space, so imagine that as being, say, a river, and then a beach, and out to the marine realm over there. So that would be the sort of kinds of transitions and facies that we're looking at. These depositional environments don't stay in the same place. They move in space backwards and forwards with changing sedimentation rates or rising sea levels or other changes of that nature. So what happens in time, so let's imagine that our axis up this way is in time, is that we get a change of our facies locations, and again another time step through time. So if you now look at a vertical succession, say that vertical succession there, our vertical transitions 4 to 3 and 3 to 2 are the same as the horizontal transitions that we see there. So that's basically how Walther's law works. If we get a succession that does not have that transition vertically, so let's say we've had an unconformity, and above the unconformity we deposit the succession like this. That transition does not conform to Walther's law, and therefore that transition illustrates, or the fact that that transition is there illustrates that there is an unconformity in that vertical succession. So our 6th and final law of stratigraphy is known as the law of cross-cutting relationships. What this law basically states is that materials have to be present in order for processes to act upon them. So if we have a succession of layers or beds present and they are cross-cut by a fault and displaced by that fault, then the layers are older than the presence of the fault. Another way of thinking about things that might cross-cut each other is unconformities. So if we have a succession of rocks which is cut and eroded by an unconformity, then the unconformity must be younger than the layers or depositions of rocks because the unconformity is acting on the older pre-existing rocks. Intrusions are another thing that happens, so you can have an intruding layer coming through a succession of rocks, and that tells us that our intrusion is younger than the succession of rocks that is intruding. Okay, so having gone over our 6 laws of stratigraphy, we can now do a little job of interpretation. So here is a small stratigraphic chart, like a little cross-section of the Earth. And now that we know all our stratigraphic laws, we can in fact do some interpretation on this. We can work out in what order the different layers and units and things and events have actually happened. So the law of superposition tells us that our oldest rock unit should be at the bottom. So that's this one down here, unit I. This one is at the bottom of our succession. It is overlain by H and G and F and E in succession. These rock units are tilted, and the law of original horizontality tells us that they should have been deposited originally horizontal, so they have been at some point tilted. They are also cross-cut by this fault, and they are also cross-cut by this intrusion, which is marked with little plus symbols and unit J. The law of original continuity tells us that these units should continue. So they are being cross-cut and truncated by our intrusion. Overlying these, we then have a succession marked D, and there is an unconformity marked by this wiggly line in between the two. Now, unconformities, like the units above them, also correspond to the law of original horizontality, so they should also be created horizontal. The fact that the layers are dipping at a different angle to the angle of the unconformity tells us that this tilting event must have taken place before the unconformity was created. The fault is offsetting unit D, so it must be younger than that unit D, but it does not offset the unconformity marked C. So therefore we know that our fault is older than the unconformity C, but younger than the unit D. So bearing all of this in mind, we can construct a bit of a stratigraphic chart for this succession. The oldest unit is I, and then we have deposition of H and G and F and E. And then we have this intrusion of the unit J into that succession. We also have some tilting, and we have our rows of unconformity. Deposited on top of our unconformity, we have unit D, which then has a fault across it, and also some tilting, because that as well is not at the horizontal angle that it should be to conform with the law of original horizontality. We then have another unconformity, C, and then units B and A. And that allows us to build up a history to create this stratigraphic relationship. And it's that kind of information and use of the laws of stratigraphy that we use every day as stratigraphers to try and work out the history of the Earth.